All right, there we go. So, anyway, we left off, right, okay, last Friday we had kind of talked about just kind of now applying these concepts, these big ideas that we've learned about the fundamental theorem of calculus, right? So, way back at the beginning of last week, we learned how to evaluate a definite integral without needing to use geometric formulas and all that jazz, okay? It involves finding the antiderivative and then evaluating the antiderivative of your function from a to b, f of upper limit minus f of lower limit, okay, the original function there and stuff like that. Let's see here. Anything else? Right, we also learned about how to find average value of a function, right, which is like related to the average rate of change, right? You remember that, right? Average value we integrate. So given a function and we want to find its average value, that's where we use this integral, okay? Given a function and we want to find its average rate of change, that's where we use our slope formula there, okay? So slight differences in that, okay, depending on kind of what we're given and what we're looking for, how we do that. Let's see here. So yeah, we learned how to do this integration with our calculators too. All right, then we apply the second fundamental theorem of calculus, right, which is taking the derivative of an integral. So at the first fundamental theorem of calculus, we really don't like refer to it too much because it's just like what we do when we evaluate a definite integral. The second fundamental theorem of calculus, right, that's when we take the derivative of an integral and how we kind of plug in those limits of integration, and then by the chain rule multiply by the derivative of those limits too, right? Okay, and we did that little exploration there and all that fun stuff too. Talked about functions defined by integrals, okay? And so it's like kind of like combining both the new stuff that we've learned with evaluating definite integrals and area under the curve with also, though, like our understanding of graphs of f prime, right? Because if a function is defined by an integral and we have the graph of the thing that's being integrated, that's essentially like our first derivative. It is like our first derivative, right? In fact, it would be exactly the first derivative when we take the derivative of that there. Okay? So we can kind of use that graph of f prime knowledge in those kind of problems. All right? And then finally, one other big concept that we've hit in this section here too, okay, is the net change theorem, right? That when you integrate the change of a quantity, the rate of change of a quantity, the result is the total accumulation or net change of the quantity, okay? The change in the amount, okay, that you've got there. And we've used that in a variety of ways. In one sense, we've used it just to find the accumulated amount from a time A to a time B, right? But we also can use it to help us find initial amounts, we can use it to find, final amounts, starting with an initial amount and then integrating from that A to the B where we want to know of the derivative. And then we can also find initial amounts or really any other location we want using, this kind of setup right here. Okay? So we did some problems with that. Took a trip to the Golden Trough. All right. And then did some more problems there. And then we finally did something. This is actually an old free response question from an AP test right here. Okay? Again, a very popular kind of question to ask where you have like a rate in and a rate out kind of thing. Okay? So today our goal is to kind of get through example 20 and example 21, and that's it. Okay? So we're just going to go through 2 here. We'll probably do 20 together. And then 21, I'll let you guys kind of like wrestle around with a little bit, okay? 21 comes from a Form B, so maybe you don't care about this, but it's helpful to know this because it might, I don't know, it's helpful if I can refer to it later, but stuff like that. But so the AP test has like a kind of like the normal test that like most everyone takes, right, on like the normal AP test day. But then for some situations, some students, right, they're unable to take the test on the AP test day. You do not get the same test as everyone else does, right? They get a Form B version of the test that you take later, right? So if you ever had like 3 AP tests on the same day, that means that you won't be able to take one of them kind of thing because that's the way the schedule works out. So they have you take it later. The Form B version is normally just like funkier, okay? Like normally there's just like a little bit different kind of question. I won't say like harder, but it's just more different than like the typical one. I don't know if they write it purposely that way because I don't know. But anyway, this is from a Form B, and so it's not like as typical, but it's still pretty good practice. All right, but we'll get back to that one later. Okay, so right now let's take a look here at number 20, okay, and kind of see what's going on. All right, so we've got a function here, right, defined by an integral. Super important here to recognize, right, just like from the homework where our limit of integration, our lower limit of integration is 2. All right? You look at the graph here, the leftmost endpoint is -2, right? But we are not integrating from -2 forward. We're integrating from 2. So that means in some cases we're going to integrate backwards, right? In some cases we're going to integrate forwards here. So it's important to recognize that here. If we're integrating f from 2 to x, for some x values here we're going to be integrating backwards, and some values we're going to integrate forwards. Okay? So it's key to recognize that. Key to recognize that here. Okay? So for our first question here, we're asked to find the average rate of change of f. Okay, so we are given, okay, what are we given here? We're given capital F, right? And we want to find the average rate of change of f. So, which of our two average, kind of like ideas are we going to use here? We're going to use the f of b minus f of a over b minus a, or we're going to do 1 over b minus a times the integral from a to b. It's the first one. Yeah, it's going to be the slope here. Okay, it's going to be the f of b minus f of a over b minus a. Okay, why is that? Well, because we're given f, and we're asked to find the average rate of change of f. So that is the rate of change formula, okay? How would it be worded? How would it be worded if we wanted to find the average value of f? Well, then you would just say something like, find the average value, of f. Yeah, there's not really, okay? That would lead to the 1 over b minus a integral from a to b of f of x dx kind of thing. But since we're asked to find the average rate of change, that is f of, in this case, 4 minus f of 0 over 4 minus 0. Okay, that is exactly what we want to do here. Okay, I didn't get to finish reading the whole directions up here, but the graph of f, little f, lowercase f, is shown to the right, consists of 2 line segments. So there's 1 line segment, there's 2 line segments, right? And a quarter circle. So you can see there's your quarter circle right there. Okay, quarter of a circle. So to find capital F of 4, okay, to find capital F of 4, that's going to be the integral from 2 to 4 of f of t dt. Okay? So from 2 to 4. So here's 2, here's 4. That is this region right here. Okay. So we're going to use geometry here, right? We're not expected to actually come up with, some function here. We'll just use geometry to get this area, okay? Don't bother trying to write a function for this. Just use geometry, right? This is a quarter of a circle. So it's going to be 1/4 times pi times the radius of 2 squared. So it's just going to be pi. Okay, so for capital F of 4, it's going to be pi minus, and then what's f of 0? Capital F of 0. So we're going to go integrate from 2 to 0 of f of t dt. All right, so now from 2 to 0, I'm going to kind of change up my, okay, so from 2 to 0. Well, what kind of shape do we have there from 2 to 0? Triangle, okay, area for a triangle is 1/2 times the base. What's the base? 2 times the height, 2. But then since we're integrating from 2 to 0 here, what's the sign of our answer going to be? It's going to be a negative. Yeah, we're going to make it negative here, okay? I might call like the base -2 there in this case, so it's going to be -2 times 2 is -4, times 1/2 is -2. Okay, so f of 4, pi, f of 0, it'll be minus -2 over 4, like that. Okay. We subtract the value of f of 0. F of 0 is a -2 because we are integrating backwards. Yes, the area, the region here, is above the x-axis, but since we're not integrating from left to right, we're integrating from right to left, that will be the opposite sign of what it would normally be. So integrating from left to right, +2. Integrating from right to left, now it's not -2. Okay? And that's that whole property, if you don't recall, That's a whole property here. The integral from 0 to 2 of f of t dt is equal to negative integral from 2 to 0 of f of t dt. Right? When you switch your limits of integration, when you flip-flop them, you get the negative, you get an opposite of the value there. Okay. So that's kind of the situation here. All right, so anyway, we end up with pi plus 2 over 4. Okay, pi plus 2 over 4. Okay? All right. Letter B. Determine the interval where f of x, capital F of x, is increasing. So, if we want to know where a function is increasing, what do we normally look at? The derivative of the function, right? So we're going to find capital F prime of x. All right? So if capital F of x was the integral from 2 to x, f of t dt, we're going to be taking the derivative of an integral here, right? Because it's capital F is defined as an integral, so the derivative of an integral, all right? What do we use to take the derivative of an integral? What theorem do we use? Second fundamental theorem of calculus, right? And so the derivative of an integral, it's going to be f of x times the derivative of x, which is just 1, minus f of 2 times the derivative of 2, which is 0. Okay? So in other words, the lower limit cancels out, and so essentially capital F prime of x is equal to lowercase f of x, like that. Question?
Would we have to show that, or could we just like?
You can just say it. Yeah, you can just get to this part right if you want to. That's
okay,
fine.
because I was like, I didn't think so.
Yeah, no, it's not necessary. But again, just because we're doing notes and stuff like that, I want to be, thorough. Make sure we're on the same page there. But yeah, you can jump down to this point, I would say. Okay? So, when we want to determine when our function's increasing and we look at the first derivative, okay, what are we looking for in the first derivative to determine when our original function is increasing? When the first derivative is what? Greater than 0. Positive, right? Okay? So where is our function positive? Well, from 0 to 4 and then 4 to 6. And I think it's okay to include the 4 because at that instant, to the left, the function will still be positive. To the right, the function is still positive. So I think it's okay to say just 0 to 6 there. Okay? So f of x is increasing on 0 less than x less than 6. Justify your answer. So because, and here again, you might be able to get away with just saying capital F prime of x is greater than 0 here. But I like to say capital F prime of x, which is equal to f of x, is greater than 0. Okay, on this interval. Maybe I should put that here too. Okay. In the past, we only had to put f prime, right? We only had to say f prime is greater than 0. But in the past, we were given the graph of f prime, right? Here, we're given the graph of like lowercase f, which we have established here is equal to capital F prime. So I think, here's what I'll say. Maybe it's a better way to say it, okay? If you've already established this in your problem earlier, in the earlier work, then you could probably get away with just saying capital F prime is greater than 0 on this interval. That's fine, because you've already established this here. But if you haven't already established this, I think it's important to establish that these two are the same, okay, in your description then. All right? Just to make sure that you are kind of connecting the information you're given with how you're analyzing things. All right, question on any of that, though? Yes.
So can you help define how you found the derivative again?
Sure. So capital F is our function that we're asked about, right? When is capital F of x increasing, right? What do we do? What do we look at to determine when a function is increasing? We look at its first derivative. So we take the derivative of this. How do you take the derivative of an integral? Second fundamental theorem of calculus. Follow me so far? Okay. So we take the derivative of the integral. X goes in for f. 2 goes in for f as well, but then you multiply by the derivative of 2 and the derivative of x there, so it ends up being just f of x. And so then you go from there. Does that make sense now? Yeah. Okay. All right. Letter C. Find the critical numbers of capital F of x and identify each as a relative min, max, or neither. All right. So how do we find critical numbers of a function? What do we do? Set the derivative equal to 0 or when the derivative... Well, okay, I was saying when the derivative doesn't exist, right? Critical points are when the derivative is 0 or does not exist. For relative extrema, do we need to include the endpoints? No. Okay? In fact, do not include the endpoints. Those are not candidates. You know, we don't want to count those as candidates. Critical points are when the derivative is 0 or the derivative is undefined. So, okay, so the critical numbers, where is our... So again, this is the derivative. So where does it equal 0 or undefined? 0 and 4. Okay, x equals 0, x equals 4 there. Exactly right. And so we want to identify as a relative minimum or relative maximum or neither. No justification here is necessary. We could give it. We don't need to give it here. So at 0, do we have a relative min, a relative max, relative minimum, a relative maximum, or neither here? We have a relative minimum. Okay, what would our justification be here? Because f changes from negative to positive, or f of x equal to f prime of x changes from negative to positive at that point, yeah. So we don't need to justify, but I might just write it out anyway, because why not? It's notes, right? At x equals 0 because, okay, capital F prime of x equal to f of x changes from negative to positive at this point. Okay, what about at 4? Do we have a relative maximum, a relative minimum, or neither? Neither, right. Okay, and what's the reason for that? Right, exactly. Okay, so you could say something like, you know, because the graph of f prime of x doesn't change from positive to negative, or, excuse me, negative to positive at this point, something like that. If you wanted to, but again, we'll just say neither. Okay? X equals 0. All right. Letter D, find the absolute extreme values of capital F of x. All right, so now since we're trying to find the absolute extreme values, that means absolute max, absolute min, what do we need to consider? The endpoints and the critical points, right? And so we've got our candidates here. So we have x equals -2, x equals 0, x equals 4, and x equals 5. Now, let's consider here maybe if we can, well, figure out, right? So what's 5 going to be? Ah, that's why. 6. I can't read the numbers on the paper there. All right, so sorry. What's 6 going to be then, okay? Can we identify? So if we're integrating from 2, right, because the idea is to find these extreme values, that means we're going to be doing f of -2, f of 0, capital F, sorry, capital F of 4, capital F of 6, right? So capital F of -2 means we're integrating from 2 backwards to -2. So we're integrating from 2 back here to -2. Okay? So like, well, we're going to lose some area here because it's positive, but we're losing it because it's right to left. But then when we integrate from 0 to -2, we're going to gain that right back because it's like the exact same area from the symmetry there. Okay, and though it's negative, we're integrating from right to left, so it ends up being a positive value. So this area and this area are going to cancel out. You're going to be right back to where you were at the 2 there. Okay, but then from 2 to 4, we will add to our value here, our y value here, right, because positive area. And then from 4 to 6, we're going to add more because, again, that area is above the x-axis there. And so we'll get some additional value there. Okay, so we can actually calculate it, though, which is really nice. So we don't need to like do this long justification. We can just show the work. So it'll be the integral from 2 to -2 of f of t dt here. Okay. So what will the value of this integral be when we integrate from 2 back to -2 here? It's going to be 0. Okay. If you don't believe me, again, we're integrating from right to left. So this first triangle here, right, that's going to be a -2. But then we're going to integrate from right to left here. It would be a -2 area, but because it's going backwards, it's actually going to be +2. So it's going to be -2 plus 2, which gives you the 0 there. Okay. F of 0, from -2 to 0, or from 2 to 0, I should say. We did that earlier. Whoops. Okay. The integral from 2 to 0 was -2, if you remember that, right? So we got that, -2. Okay. It's supposed to be a dt there. All right, and let's do 2 to 4. Okay. 2 to 4, we've got that one too, right? We did that earlier too. Integral from 2 to 4 was pi. And then the integral from 2 to 6 of f of t dt. We're going to add that pi plus, and then the triangle here, which is 2 by 4, so 8, but then half of that will be 4, so pi plus 4. Okay. So this one's nice. We can actually evaluate all of these values of our function without having to come up with, without having to kind of do this long justification. So the absolute maximum occurs where? Okay, at the 6, and you can even say 6 comma pi over 4. Or 5 pi over 4, pi plus 4, sorry, pi plus 4. Oh, I said pi over 4. 6 comma pi plus 4. Okay? And the absolute minimum occurs at, and then where does our absolute minimum occur? 0 comma -2. Okay? When you're talking about extreme values, there's kind of like 2 different questions that could be asked as far as when you're talking about the extreme value itself. You could be asked for the location of the extreme value. That would be, of course, the x coordinate, right? Or if you ask for what is the extreme value. The value refers to the y coordinate here. Okay? Since I don't like having to worry about x or y values, I like to just give the coordinate. So when you can give the coordinate, I suggest you give just the coordinate for the point. That way you cover your bases. You don't have to worry about interpreting there.
So
Sean?
for this one,
Mm-hmm.
so you're trying to get the extreme values, you're finding the absolute maximum and absolute minimum. Could you just look at the graph, and since it's the values for f are negative from -2 to 0, since 0 would be the lowest, wouldn't that have to be the minimum? And then could you do it that way?
I think yes, you can kind of use geometry here to help you figure it out, absolutely. But what I would say, though, is that it says find the absolute extreme value, which when you hear the word value, that means it's asking for the y value there. So giving just a 6 or a negative, or I guess a 0 there, that would indicate, that would just be the location. You want to come up with the value, so you would need to actually do the integral and stuff. So in other words, to answer this question, you don't need to give the fact 6 comma pi over 4. You could just say the absolute maximum value is pi plus 4. The absolute minimum value is -2. Okay, you can just give the y coordinates there. But I like to, again, just give the actual point when you can, because then you don't have to worry about whether it's the location or the value. All right. Lastly, letter E. Find the intervals in which f of x, capital F of x, is concave up. And explain your reasoning. Okay? So, what do we look at when we're talking about the concavity of a function? What do we like to use? The what? Second derivative, right? Okay, but all we've got here is a graph of the first derivative. If we're looking for when our function is concave up, we want to know when our second derivative is what? Positive. So, okay, we want f, capital F prime of x to be greater than 0 is what we're looking for here. All right. So we look here at f, which is equal to capital F prime of x. Okay. If our second derivative is positive, how will that show up in the first derivative? Increasing, exactly right. So the question really is, where is f prime increasing? From -2 to 2 and 4 to 6. Okay, right. So, for -2 less than x less than 2 and 4 less than x less than 6 because, and again, what was the thing that we looked at, right? We looked at f prime of x, which is equal to, lowercase f of x there. F prime of x, which is equal to lowercase f of x, is increasing on these intervals. Okay, I think that is sufficient, but again, I'm just going to go like the one. Oh, sorry, Sean. Yep.
I'm confused. What happens between 2 and 4?
What happens to the function? We're decreasing here, aren't we?
Wouldn't it still be positive?
So, okay, what is positive though? Capital F prime is positive, so therefore capital F would be increasing. But the derivative of this thing, right? The derivative of this thing, which is f prime, lowercase f prime, or capital F prime prime, okay? The derivative of this thing would be negative from 2 to 4, right? Are you okay with that? The derivative of this thing would be negative from 2 to 4 because you're decreasing. Well, the derivative of this is capital F prime prime. Means capital F prime prime would be negative. Original function would be concave down. Does that make sense? It is asking for capital F. So this is capital F prime right here you're looking at. So then its derivative, the derivative of this thing would be capital F prime prime. Double prime, right? This is capital F prime that you're looking at right here. The first derivative of capital F, right? Its derivative will be negative for this interval. F prime prime will be negative for this interval because F prime is decreasing on this interval. Follow me so far, right? Okay? So that's the idea there. Yes. All right. All right, so again, I'm going to finish this off here because, again, we could stop here. I'm pretty sure that's sufficient, but I'm going to add on just this last step. So we said capital F is concave up for these two intervals because capital F prime equals f of x is increasing on these intervals. This indicates, that f prime prime of x is positive. So f of x will be concave up. Okay, just like that. All right, questions on number 20. Okay. So the 21, I'll read through it here with you, and then I'll have you guys give it your shot here, all right? And then we'll come together, of course, afterwards and go over it. All right, so let's take a look at 21 then. 21 is more akin to that amusement park problem that we did. Okay, right, where you had people entering and exiting and stuff like that. Okay, it's more akin to that. So we'll, you keep that in mind. Okay, not so much like this one where we have a graph and stuff like that. Okay, so we've got a water tank at Camp Newton, holds 1,200 gallons of water at time t equals 0. All right, and so during the interval, thanks.
Today, we're back. Tomorrow, that one. Wednesday, just this one. But it says on the calendar number 5, not that one.
Okay, so this is for front and back today, and then I'll have these out later. Okay. Wunderbar. Thank you, Mr. Goff. So again, a water tank at Camp Newton holds 1,200 gallons of water at time t equals 0. During the time interval 0 less than equal to t less than equal to 18 hours, water is pumped into the tank at the rate here. Okay, so obviously this is a calculator active question. Okay, during the same time interval, water is removed from the tank at this rate, gallons per hour. Okay, is the amount of water in the tank increasing at time t equals 15? Why or why not? To the nearest whole number, how many gallons of water are in the tank at time t equals 18? And then at what time t, for 0 less than equal to t less than equal to 18, is the amount of water in the tank at an absolute minimum? Show the work that leads to your conclusion. And then finally, for letter D, for t greater than 18, no water is pumped to the tank. But, so again, after that t of 18, no water is pumped to the tank, but the water continues to be removed at the rate r of t until the tank becomes empty. Let k be the time at which the tank becomes empty. Write, but do not solve an equation involving an integral expression that can be used to find the value of k. Very common style of question here. We are asked to set up but not solve an integral here. Okay. Typically that means you get points for the right limits of integration and the equation and stuff like that. Okay, and the integrand and stuff. All right. So go ahead, give this a try. And of course I'll come around and help you. All right, but not too much. Yeah.
Here's the problem sets.
Oh, thank you.
So this didn't get stapled, so can I look through the whole
Oh,
see it?
yes. Well, here, I'll let you get there. Yes.
Oh my god.
I think so. So it's booting up. It's supposed to be like newer, but it's refurbished, so it's kind of like older looking. It's a 84 plus silver.
You were making fun of my things for my being fake, and you're super
I was?
Yeah, you're like, I think that would find the amount of water.
No. I didn't like the color screen because it like it's slower. And this one is slow. I agree.
But I do. Yeah, you're gonna look at the rate.
So you just plug it in?
Where do you get it?
Let's see if it's still the same.
What?
Yes. So, like, you have three functions in graph, you mean?
Because like one's positive, the second
So you have some options. I mean, option one, well, I'll let you describe it.
because basically
So option one, if you go to your y equals, you can toggle off those two equal signs. That's option one. Now, option two, if you want to leave those stuff on here, so you do the same thing you normally do with the zeros command, right? But you'll notice that we're on y1. If you use the up and down arrows, it switches to different functions, and so then you can just go left and right that way.
Right?
So-
You're still looking at the rate.
So yeah, the question is, right, the question is the amount of water, so that makes we're talking about rates or means increase, but we're talking, is the amount of water in the tank increasing? Now we're talking about the rate of change of the amount of water in the tank, right? So let's say we had some idea of the amount of water in the tank, we had that thing. We want to know when it's increasing, what do we look at to determine when something is increasing? The rate of change, it's derivative, right? The derivative describes the rate of change. So, we've got a quantity, we want to see when it's increasing, so we look at its derivative. Well, what kind of thing is going to describe the rate of change of the amount of water in the tank? Well, I'm talking about the one we got right here. What's an expression for the amount of water, how the amount of water is changing in the tank at a certain time t? Yes. So you have water going in, you have water coming out. Ooh. Because W is the amount that's being filled up, and R is the amount of being removed. W is being added into the tank, R is being removed.
If it's positive, that means
Yeah.
it's still.
W of 15 is specifically minus R of 15.
So can you tell me why my thought process is wrong for this? So for A, my initial thought was
See, and then
to
B, we take the derivative.
plug in 15 for each equation.
Mhm.
And
That's
then-
right.
And then like see which one's greater.
That would work, I guess, but you want to treat the R1 as like a negative, so really you could do W, it would be better to do W15 minus R15.
Oh, is that what you're supposed
So
to
you
do?
kind of have the right idea there, right? If R is, so if this were the greater one, then you would say that the rate of change is decreasing, I guess, but then you want to see when.
Would it be the same if I had just found the values for both and subtracted R from 1200, but added-
Not from 1200. You subtract them from each other. These are rates. This is a quantity, so you can't. They're not like terms,
Okay.
right?
All right. Oh, well, yeah, I see what you're saying.
Okay.
Gotcha.
Yes. Because the amount of water in the tank is changing based on two things, right? We have water both coming in and water going out. So you have to consider simultaneously, both of those, right?
And then is it over? So it's not like over.
No, because it's like the rate in minus the rate out. Okay, so that'll give you the rate of change of the water in the tank. Just like with the card, right? If you're coming in, coming out, kind of thing. So if you subtract those, you have the rate of change of the number of people in the part. Here's the rate of change of the amount of water.
For B, does that mean that like just add them together then?
So now you want to find an actual quantity. How many gallons?
Oh, so then that was what I was saying. Like,
Those are rates.
so I'm plug in 18 for both of them and then just like combine them.
Careful. If you plug in 18, this is top and bottom one, you're going to get the rate times 18. You want to come to the actual quantity.
So I have to integrate that out.
And go from what to what?
From 0 to 18.
What will you be integrating?
I'll be integrating both.
Well, okay, how's it going to set up though? What do you mean by both? Like you're going to do this one from 0 to 18 and then separately this one from 0 to 18? Okay, so then what would you do then in the end? You would need to subtract those values, right? Because if you integrate this from 0 to 18, that's not the water that's come in. If you integrate this one from 0 to 18, that's not the water that's coming out. You want to know how much water is in the tank.
I'm going to subtract only R and then add W.
Right.
Oh, okay, good.
Yeah, so that's on the right path there. But consider all the information given on that tank too. Okay, consider all the information given on that tank. Yes, and then I'll write this. Correct. You want the square to be like that. No, you did it right. Yeah, that's right. Yeah, that's right. You can also alternatively put like a group of parentheses around. I know it's like how many parentheses we need, but you could put a group of parentheses around the sign function and then square the function. It'll be the same thing because you can close it. Yes. Beautiful.
Okay.
For letter A.
Second.
If I would put 15
Great. So
13
parentheses.
I have no clue.
That will evaluate it at 15. Yeah, I know.
Oh, I must have done something wrong then, because, watch this.
Oh, your cutter doesn't let you do it.
Oh my goodness. Why did I just like that?
Okay. So yeah, 95 square root of t times sine squared. 95 square root of sine.
Is the integral.
No, that's okay, but you see you missed the t.
In order to
So
take,
insert x,
in order to find the integral.
close that parenthesis, and then open that parenthesis. So you see that's what
Okay, so I just put it like that backwards.
yeah, so but you're okay. Yeah, the square at the end, perfect, exactly what you want to do here. I mean, you could have put this as well.
Technically,
Yeah, that should work, that should work. Alright, so let me try it now. I'm not
Wait, no, if you plug it in, you can get a graph and use it.
This is this class.
So wait, would you subtract this from
Well, so, hold on, let me try one more thing. We have an admin right here.
Wait, did you really do
Okay, so.
This thing is whack.
I have no idea why it didn't. I don't know.
Oh my.
I don't know what I did. Try. So try that one more. You type it now and just see what it is. I have no idea. Yeah, if I have this again, let me know. Okay.
We do.
Alright, we go around here.
Yes. Got it. I know.
That 30-second block. So like I hadn't given away all my
Let me
cards.
go to teacher real quick.
Yeah, at first I was like, wait.
The day
I forget about the tag.
Day of.
Okay.
Or the day. The day of, I was going into Michelle Wolfer's house and I saw like the resource officers and all the administrators. They told me to go there.
So,
Like I was walking back without like my desk.
consider
To
this.
the other side.
To consider.
Yeah. I was literally right down the hall.
So consider 18. Well, so you want to know when the you have a thing that represents. How do you know? You have a thing that represents like the quantity of water. It's like 1200 plus 0 to x of w minus r. Right? Right there, one second. Right, like this is like. No, wait, you told me your way. Right, like that's like this, like the non-water you're saying. 95 cents. So that means we want to find the absolute like the absolute minimum. No, that's max. Minimum of water in the tank from 0 to 18. So to find out the minimum, you want to take the derivative of this. Because that's my critical point. Derivative of this. So find the zeros of this. Right? Well, you have this. So
I was trying to understand what you were saying.
and solve. Absolutely. Right? Okay. That's right. Well, what part of, like, this is exactly what you're supposed to say. So, okay.
What'd you get from C?
Right, you're
I
getting
will
rates
continue making, I
about,
will continue eating
so
my
yes,
ramen. You don't owe me anything.
Yeah. What did you say 0 to x?
Oh, it's just as you go to school, it's by my
okay, I'm coming.
My mom just texted me.
Okay. Nice.
Yeah.
So, is the amount of water, okay, so you see amount, that's good, and you think, okay, we're given a rate, so you want to integrate, is that what you're thinking? Okay.
Oh, okay.
Increases. So, right, so the rate of change of the amount is back to the rate step, okay, so we're not going to consider the actual quantity somewhere. W15 is the rate of water going in 15, and then what else is affecting the rate? Or R, so minus then R of 15. The rate going in minus the rate going out is the rate of change of quantity in the rate of time. It's like the equal and the inverse part.
What?
You have the rate of entry part, rate of equal part, and the rate of the
Well, I
in the part. Like all of them have to make sense?
Yes.
I do. So what do we consider the absolute, right? So we have to consider the endpoints of the intervals, right? So
this up for like our function to think about the amount of water in the tank. Does that make sense? We kind of use this to let B essentially. Something like that. Did you do this? 0 to, not actually, you did like 0 to like 18. You did, right? And then you added this to it, right?
No, I didn't, but I need to.
Yes. Right. So then that's your function as the quantity of water in the tank.
Okay.
So then how do you find the critical point? Take the derivative of this thing. What's the derivative?
Oh, cool.
And that's equals. How do you know when it's equal to 0? Alright.
No,
Yeah. So where you plug those back into your critical points, you go back into the original function. Or maths. Now it goes down. Alright, right there.
Yeah, so you guys will take a 3 on calc.
Yes, absolutely. Sounds like a really statement type of
Okay, I'll see you. Yeah, 411.
Okay. So be careful here. This is the amount of water
But I did apply to
how much water was in
Yes, that was
Okay.
that's such a
So that's your final answer. Plus there's okay, I got you. So this thing represents the net change of the amount of water.
I unsubscribed from at least 5
Plus this
emails.
interval, that gives you the quantity of water in the tank at any time t from 0, like you integrate from like 0 to x. So essentially like,
Oh, yeah, you definitely could have. But you don't have to try.
you see that, right? Okay. So how do we find absolute stress? What do we do? Critical points. So what are critical points? When the derivative
What was the first one?
equals
Did you
0.
check the like contact window?
Right? So it's basically just this minus this when it's equal to 0.
If you do.
And then also your endpoints, your interval. And then since you got your calculator, you can do all those integrals with your calculator, right? You can say, okay, from 0 to 0, 0 to 18, you've got those two already, and then from 0 to you're gonna have to do
It's hard.
Yeah? Okay.
And I can't, I freak out if I had that.
I have ones that
By the way, folks, remember you would have 15 minutes for this question. You would have 15 minutes for this question on an actual test.
Yeah, I have the first value. I do, but.
Because what are you trying to find?
Why do I even choose
How do you find absolute stress? So I disagree with representation. You're not adding the net change, the water in right? And the derivative of this thing must equal 0 to find your critical point, right? The 12 equals 0, the derivative equals w of x or no. Wait a minute. Where's your A, it's just w 15 minus r 15, that's it.
Why didn't we just do the whole
No, these
I literally qualified for 0.
No, you're right.
I don't know, I don't think I know anybody who actually qualifies for 0.
okay, first off.
I actually want to figure out. So it's at.
Or at the point where anybody's done.
So,
First of all, why am I even talking about water?
What is affecting the
I don't know.
Right? You have water going in, you have water going out.
My dad makes the track page.
You have the rate of water
I just didn't do the graph. It's crazy. My dad takes very. So he literally has like 4 teams. There are 5 teams. So he is 4 working posts at that 5
There's more water going in. Because this is showing how much water.
But I'm just like 2 separate times. My mom's gonna say
This is the net change. Right? This is like the net change from water tank. So you understand it's just the change. Do you know anything about how much water is in the tank? So right, at time t, you got 1,200 gallons of water, which means that how much water you actually have in the tank after those 18 hours. They're not going in. It has all the positives. They're all gaining water.
That's all. Every single
If this number ends up as negative, this is all they use. Like you always want to add
everything from the original he just has a stack of icons in his calendar. And it's changed all of the icons. And
What are your values? Calculator again. That's what you should do. Yeah. Calculator. You put 0% calculator. X values is 0.
And then, of course, when you have the original graph and the endpoint interval, you sum all that in. Oh, to your original amount, right? So your
it's just so weird. They like treat them to all of us weird and they literally fly him around to have like a fancy business. It's not even for any purpose to sell anything. It's just his getting a fancy dinner.
Are you having? I know I've been wanting a while. Are you having a graph and
I would start, but I have no idea.
this is
Yeah.
this problem does. Yes. Making them happy.
Yeah. I think you're gonna find wrong. Again, you're welcome. Look at this capital A. Like, right now.
What? Yeah.
Yes.
I would suggest. Yes. Yes. That's right. Yep. Very good. Good with the 1200 there too. Okay. Let's use the last bit of time that we have here to kind of go over this a little bit. Okay. So tonight's homework is this page that I just handed out to all of you. Okay, that will be tonight's homework. All right. We actually printed it out for you because there's like graphs and stuff, so we thought it might be helpful to actually like be able to draw on it or like write on it and stuff like that too. Okay, and we encourage you to do that. Okay. That being said, let's kind of go through some of these questions here as best we can because we are going to run out of time. All right, we probably won't get through it here. Okay. So, we already read through it, so I don't want to read through it again, but we'll talk about letter A here. Is the amount of water in the tank increasing at time t equals 15? Why or why not? So, we have information about the water going into the tank. We have information also about the water being removed from the tank, but we're asked about the amount of water that is actually present in the tank at any particular time t. And so for letter A, that's going to be a result of then doing the amount of water going in at time 15 minus the amount of water going out at time 15. Okay, just like that. So when we do that, we get approximately negative 121.09. Okay, that is less than 0. Okay, so is the amount of water increasing? No. How can we tell? We have a negative rate of change here of the quantity of water, okay? So no, and then with reason, because the rate of change of the amount of water in the tank is negative. Okay, letter B. To the nearest whole number, how many? Now we're talking about an amount. How many gallons of water are in the tank at time t equals 18? So if we're given rates and we want to find the actual quantities, that means we need to do what? Integrate. Yeah, Emma, question?
A question on the first one. If this rate of change, why is it not over anything? Why is it just...
So we're not asked for average rates of change or anything like that, just a rate of change. So we're given rates of change, so we can just subtract them to get then the rate of change of quantity. Yeah, if the average part was there, then you have the over b minus a or that kind of thing. Okay, so integral from 0 to x, I like to say this, okay, of w of t minus r of t with respect to t. Okay, so there's an expression for the net change, right? The net change, right? We integrate from 0 to x, whatever time. In this case, we want to do 18, so maybe I should just do the integral from 18. That might be better. Actually, let me just do it this way. So from 0 to 18 of w of t minus r of t dt. But again, this is just the net change. Okay, when you get this answer here, you get something like 130.788. But is the answer 130.788? No, because what else do we know about this tank? It started with 1,200 gallons already in it. Holds 1,200 gallons of water at time t equals 0. So this is the net change from time 0 to 18. So we're going to do 1,200 plus that 130.788 gallons. And that is our answer, okay, which is like, what, 1,330.788 gallons. Ooh, but it did say to...
No, like...
Yeah, instead of 130.
Yeah, instead of the 130, I got 109.
109?
Yeah. 110.
Oh, yeah, okay, it should be 109. I must have mistyped something in my calculator. So, yeah, it should be like 109 point what? Okay, so 0.788, sorry about that. It's supposed to be 109 as well. And so then it said to round to the nearest, oh, it didn't say that. Oh, to the nearest whole number, So it should be 1,310 gallons. Should be your answer there. Please make sure you round, to the nearest whole number there. So 1,310 gallons. My mistake. Okay. Finally, letter C. Okay, and maybe we'll stop there. I don't want to push this time. We'll go over it tomorrow. Okay, we'll finish up letter C and D. Okay, if you didn't get a chance, try and finish up letters C and D though tonight too, in addition to your homework. Okay, and we'll just stop there.